So thanks everybody for coming. This is our third webinar in the last couple of months, and yeah, I really appreciate everybody taking some time to come out, and hopefully it's informative and somewhat entertaining for everybody. So this is a webinar to talk about some of our experiences with flow monitoring in support of new subdivision I&I prevention. So just a few housekeeping items. So this webinar consists of a couple parts. So we'll have the presentation and we'll go through that, and then we'll leave time at the end for Q&A and some discussion. If there's those that have points out there, we can leave that at the end and certainly address some of those questions or discussions around some of the content that you see today. If you do have any questions, there should be a little Q&A or chat box at the bottom. As you're going through, feel free to, as we're going through, feel free to put your questions in, and we can certainly address them at the end. And at the end, if there are people that want to ask questions, and you can put up your hand and we can put you on camera, or at least unmute you so that you can ask a question. We can have a discussion that way as well. There are a few polls throughout the webinar, so feel free to look out for those and answer those as you see fit as we go through. I also just wanted to touch on, today is a National Truth and Reconciliation Day. It's the first time that's happened. A newly implemented sort of awareness and holiday around that. So I know a few municipalities reached out indicating that they couldn't make it today. So we set up separate time for them, and we'll be recording the webinar and sharing that as well. But just wanted to sort of take a second to recognize that and allow people to maybe reflect on what that means to them, what this day means to them, and before we get started. Okay, so the agenda, so a lot to get through, so I'll rip through this, but we'll do a bit of an introduction to Civica and to the people that are talking today, and some of you may know us and others may not, so we'll do a brief intro to the company and to who we are, and then we'll jump right into the content, talking about the standards and guidelines that are required for programs like this, some of the best practices that we've seen and we're constantly reviewing as part of what is a relatively new program, a status of existing programs that we're working on, some lessons learned, and then we'll jump into the Q&A at the end. And so just a little bit about Civica, if you're not aware. So we're a water resources and capacity management company that really focuses on driving innovation and driving solutions to meet drainage infrastructure capacity needs. And really a lot of our focus has been on collection systems, stormwater systems, wastewater systems. We have our own field services group, so we're out there boots on the ground doing field work. And we also have a suite of software in-house and with our sister company called Smart City Water that really helps us to provide a lot of value to our clients. And we do a lot of consulting around various capacity management efforts, whether that's I&I or modeling or things like that. And so really our mission is to help sort of build these resilient communities during this period of rapid growth and changing climate by maximizing the use of the infrastructure that's in the ground. And we've really strived to provide that value to our clients over the last 5-10 years that Civica's been around. So just a little bit about myself. So my name is Matt Malone. For those of you who are maybe not familiar with me, so I run the business development group at Civica. I have a bit of background in wastewater capacity management myself, and have worked extensively on I&I programs, both on the consulting side and as well as a stint within Peel Region, so at a municipality as well. So yeah, I've been really focused on this stuff the last 6-7 years or so. I'll pass it over to Alex. Maybe you want to do a quick intro to yourself.
Thanks, Matt. Good afternoon, everyone. My name is Alex Dean. My background is environmental engineering. I've been with Civica for 5-6 years so far, and my involvements mainly include sewer capacity management analysis, modeling, flow monitoring, I&I investigation, and remediation. For the past few years, I've been heavily involved in today's topic, which is flow monitoring, especially new subdivision flow monitoring. So I'm very happy to take this opportunity to share some of our experience with everybody here.
And Ed?
Hello, everyone. Thank you for attending this webinar. We're thrilled that you're here. My background is that I have approximately 35 years of municipal water resources experience. Most of that related to sewer capacity management and municipal drainage capacity management. And yeah, we look forward to presenting. For some of you, you might have already heard us and met with us for some of the topics. We hope that some additional topics will be brought out, and hopefully we will have a time for discussion at the end.
Awesome. Thanks, Ed. And yeah, so our first poll, I mean, we've told you a little bit about us, so we'd like to know a little bit more about you. So there should be a poll that pops up on your screen, and if you could just kind of let us know what type of organization you work for, so we get a sense of the crowd here today and who's involved. So we'll just give that maybe 20-30 seconds to populate. Okay. So we have almost 50 people on the call today, and it looks like about 70% are from municipalities, one person from a provincial or government agency, and around 20% with engineering consulting or contractor firms, and 6% others. So interesting. Awesome. It's a good mix. Okay. So I'll do a brief intro and talk a little bit about inflow and infiltration, or I&I, and it may be a topic that many of you are familiar with, so I won't spend too much time on it, but I guess just as a very quick second poll, I just want to see how familiar people are with the topic that is inflow and infiltration. So you should see another poll pop up on your screen now. All right, so got most of the answers in now. It looks like the group is either, there's a very quite a bit of familiarity, so almost 50-50, very familiar or somewhat familiar, a couple that are not as familiar, but it does seem like we have a pretty informed group here today, so that's good. So I could probably speed through these next slides fairly rapidly. But anyway, so when we talk about I&I and some issues with I&I, we really talk about what these collection systems, what these wastewater systems are designed to carry, and usually that's some form of wastewater, and then we allow for some small allowance for I&I. And in actuality, there's a lot more in a lot of systems well across Ontario and beyond where that actual amount of I&I getting into the system is above, or well, in some cases, well above the design allowance. And that leads to various issues. And so when we talk about I&I, when we talk about rain or snowmelt getting into, or groundwater getting into sewer systems, we're really looking at options at how do we mitigate some of the negative impacts that come of this. And this is just a figure that we've used in a few presentations to talk about the I&I reduction using a net benefit approach, as some of the developer-led I&I programs that we've been working on, particularly in York Region and the City of Toronto. And so when we're talking about drivers for I&I reduction, we're looking at trying to eliminate or reduce as much as possible basement flooding, sewer backups, trying to reduce or eliminate, again, certain things that may have negative impacts to the environment, such as CSOs or SSOs, or bypassing at treatment plants. You know, when we have to accommodate flows, when we have to accommodate this excess water that's getting into the sewer system, it does drive some fairly costly infrastructure upgrades. So when we have to build bigger pipes or storage or upgrade pumping stations and treatment plants, or even just treating that water alone, there's certainly some significant costs associated with that. And then finally, when we look at the rapid growth that we're experiencing in the GTA and Southern Ontario in particular, you know, if there's space taken up in that collection system, in the wastewater system by I&I, then it does limit some of the growth that, or at least the capacity available for growth. If we have to look at options of reducing I&I or accommodating those flows in some way. And so when we talk about I&I at Civica, we really have three main programs that we work on. So we have a new subdivision I&I prevention, which is trying to prevent as much I&I at the sort of inception of new infrastructure getting into the ground. We have I&I reductions, so looking at existing systems and trying to get that I&I out of the system, and then eventually, after sort of certain cost effective reductions have taken place, you know, we look at how do we develop solutions that can accommodate the flows after you've done these cost effective reductions. And so I just wanted to touch on one of the key drivers for Civica in the last few years is the York Region Developer-Led I&I Reduction Program, and we'll have another set of webinars on that program. But essentially, being able to accommodate a lot of growth through a program like that, and saving in treatment costs, and leading to development charges and things like that. So I don't want to touch on it too much. Really, the focus today is on that first program, the new subdivision I&I prevention program. But this is another one that really we've been involved in and have been very successful over the last 10 plus years since its inception. And so I'll pass it over to Alex here, but I just wanted to highlight as we go into the content for this topic, the new subdivision I&I prevention and flow monitoring to support that. Just wanted to highlight we were able to submit the work we've been doing, particularly in York Region, to the PEO York chapter, and there was a lot of hard work on from a lot of people at Civica to both apply for this, but also executing these projects and being able to successfully monitor flows and look at the performance of this infrastructure as it's going into the ground. So just wanted to highlight and sort of recognize on Alex's side anyways, the operations side, some of the good work that's been done as part of this program. So with that, I will pass it over to Alex.
Thanks, Matt. So for the next few slides, I want to talk a little bit on the existing programs, and first, what is a new subdivision I&I prevention program. So a new subdivision I&I prevention program is a program that is specifically designed to prevent I&I, not for just a short term, but more for long-term resilience in the system by implementing enhanced material and construction practices, and also confirming the results through monitoring. So there are a few active programs available right now. So York Region is the pioneer on that. So there is York Region SIP program that has been running for 4 or 5 years at least. And there's also a slightly different version also within York Region, but in East Gwillimbury, it's called SDIP programs to factor in the energy part of the equation. And I know King City is currently developing their own program on top of the York Region program. It's called SIG. And also I'm aware PO region and Niagara region, they're also moving towards that direction to have their own program. So it's becoming more and more popular. So on our side, Civica as a company, we have been involved in this type of program with York for the last, I'm going to say 5 years. Our involvement primarily includes developing the conformity plan upfront and doing the flow and rainfall monitoring work for sure. And also, if the monitoring data shows the trend is going towards non-conformity, we take proactive actions to identify and communicating methods to find these potential I&I sources during construction or after occupancy to make sure that this program is going towards the right direction. And also at the end, there's a third-party peer review required before the municipality signs off on this program. So this is, in short, how this program runs. So we'll go through some details in the next few slides. So why a new subdivision program is preferred? Well, there's a few drivers. Obviously, the primary driver is growth. Growth is happening in a lot of places, and in GTA, it's happening very, very fast. So, to accommodate fast growth within our community and make sure our infrastructure can support the growth at the rate. So this type of program is essential. This is a tool to accommodate new developments with less impact on the capacity in the downstream system, including pipes, pumping station, and treatment plants, and just to building more resilience in the system. And also, we all know I&I is an issue in older subdivision, but it's not a safe assumption that I&I is not an issue in new subdivision. And there's evidence showing that in some new subdivisions, due to some construction issues and due to some practices and some rendering issues here and there, we've seen I&I rates higher than the design allowance, which is typically between 0.1 to 0.3, with 0.26 or this type of range being the most popular. So just because this subdivision is new or it's relatively new, it doesn't necessarily mean it does not have I&I problem. And in fact, this I&I new subdivision I&I program is to make sure the chance of a new subdivision to have I&I problem immediately or a few years down the road is minimal. Also, as I mentioned, growth, so achieve fast development approvals, with an increasing focus on wastewater system capacity. For example, the new MECP, COI, EC regulation programs that support low I&I at infrastructure inception will give more confidence to municipality to approve development faster. Okay, Matt, I believe there's another poll. You're gonna
yeah, so we have another poll, and I guess this is a little more specific to the municipal folks out there, just in terms if you're considering or have a new subdivision I&I prevention program in place. So there may be a few less responses on this one, but curious if there are any sort of in planning or in progress, I guess, could be another yes to this question if you're already executing one. Okay, we'll just give it a couple more seconds. So that looks pretty good. So it looks like there's sort of 8 that are considering it, 11 in planning, and then a few that either say no or they don't know, and a bunch of NAs, which may be more on the consulting, contracting side of things. So awesome, good to see. Okay, so we'll move on to the next slide, Alex.
Okay, so next I want to just expand a little bit more to talk about how this program typically works, and first, if this program has a standard or a guideline to guide the participants to know what's the end goal. So I'm using York Region's SIP and SDIP programs as an example. So this program requires sewer installation performance testing that typically involves CCTV inspections, manual testing, air testing, this type of regular testings. And for flow monitoring, there's I&I target to achieve. So York Region's target is 0.12 liter per second per hectare, and that's projected to a 1 in 25-year storm. And this number is less than half of their I&I design criteria allowance, which is 0.26. So this is by achieving this target, that ensures the I&I is going to be far less than what the design allow for at the beginning, and even a few years down the road, considering the deterioration or aging of the infrastructure, there's still buffer room to kind of provide more certainty for future as well. So this is the standards. And also on the monitoring side, there's defined monitoring requirements in collaboration with York Region. Usually the consultant would work with the region up front to put together a conformity plan that documents or propose the plan to achieve the conformity. That usually on the flow monitoring side involves where are the proposed flow monitoring locations, and where are the rain gauge, what's the proposed monitoring durations, touch point communication plans, etc. So that's how this I guess program or standard works in a nutshell. Next slide, please. So as I mentioned, Civica as a company, we have been working with our public sector partners as well as municipal partners, in this case York Region, for the last 4 to 5 years. And you can find the program guideline, SIP, SDIP guidelines online. It's a long document, but we kind of summarize this process in a few, I guess, major steps. As I mentioned, the first one will be to prepare a conformity plan upfront before you do any actual field work or monitoring work. And then once this conformity plan is approved, so there are certain required sewer inspections and other documentation gathering to make sure these checkboxes are checked. And then there is 2 flow monitoring periods required for these 2 programs. So the first period is after the first connection happens. So it usually goes from minimum 8 months to 12 months, depending on the situation. And once the occupancy exceeds 85%, then the period 2, which is the second monitoring period, starts. And again, it's the same, 8 to 12 months usually, to collect enough data. And if the flow monitoring data demonstrates that I&I meets the criteria, 0.12 liter per second per hectare, there's a final report required to consolidate all the mandatory requirements, checklist, and the flow monitoring report. After peer review, then subject to the review and approval from the municipality, which is York Region in this case. This project, this whole program will be approved. So in this slide, we kind of just picked up some of the projects or development that we managed in the past, and some of them they're already completed, some of them they're still ongoing, kind of just to see overall where we are in terms of the I&I result within the 2 periods of monitoring. So I think that this here, the sample developments, there are 21 developments, and the majority of the development overall they're in conformity, and there are some that are showing very high I&I. One of the I guess the highest one, it's almost 1 liter per second in 1 liter per second per hectare in period 1. And the next one isn't much better. It's probably 0.76 liter per second per hectare, something like that, during period 1. And interestingly, in period 2, they all achieved conformity, and one of them actually achieved it or exceeded it by more than 50%, which is development 7, as you can see. So yeah, there are some lessons learned definitely in period 1. Once we find the trend or the data is showing there's quite a lot of I&I, that would trigger some more I guess rigorous inspection, especially during wet weather, to go out to the site and find out how and where this I&I come from. And usually during these construction phases, you will see sometimes it's the manhole or it's the surface flooding, and that creates a lot of I&I going into the sanitary manholes. So I'm not going to spend too much time here, as I know Ed is going to need to touch on that topic later on. But as you can see, the successful rate for this program is pretty high, through the due diligence on both parties, being more proactive on the data, go out during wet weather to do more inspections. Usually this target is achievable. I mean, this 0.12 liter per second per hectare. Okay, so the status of the program. So I know we have 40 plus phases of development registered in 5 communities when the slides are prepared, but I think now this number is probably higher, but we're gonna say 40 to 50 phases of development in different municipalities in York region, primarily I'm gonna say in East Bloomsbury, and in the past in Aurora and Richmond Hill as well. And most of those development, they have completed 2 monitoring periods, or they're about to complete 2 monitoring periods. So we've done over 500 monitoring months to date, considering each development usually consists of different participants. So we have usually a few monitors even at one development area to bracket the catchment area if they have different outlet locations. So this is usually required. So yeah, overall we have done more than 500 monitoring months to date, and it's ongoing. So there's quite a few, I guess, lessons learned or experience we can share maybe later on in these slides when it comes to monitoring, and also analysis and reporting. It's still ongoing with different phases of development to achieve target. The target 0.12 liter per second per hectare or better. And there's also ongoing effort to get all phases below the target. As I mentioned, you definitely need to be a little bit more proactive, even during the period of collecting data, and not just wait to the end of the monitoring period and find out the monitoring data is showing this is not in conformity, and then you miss the window of opportunity during during the current year, and then you have to do something next year, and worst case scenario, redo the flow monitoring, and that costs time and money. So being more proactive and looking after data on a regular basis is definitely a key to reach success. Okay, next, when it comes to flow monitoring, there are a few unique, I guess, uniqueness for new subdivision flow monitoring. So the nature of low flow within new subdivision definitely creates some challenges to flow monitoring contractors and technologies. So we have a few solutions here, and I can share. I will share with everybody here today. Expert insights required to select the monitoring sites is that monitoring sites, and based on the site condition, selecting the right equipment to do flow monitoring is also the key. Some of you might know area velocity meter, which is probably the most commonly used monitoring equipment in the sewer environment. But when it comes to low flow monitoring, usually area velocity meter doesn't work very well due to the nature of low flow. Sometimes the flow is so low, even the sensor itself is not submerged, and for the velocity sensor to work properly, you need to have a minimum velocity, usually above 0.15 meter per second or 0.2 meter per second, which in new subdivisions, especially during period 1, it's hard to achieve. So those considerations, we also need to factor them in when it comes to equipment selection. And also a robust tools for data access, data management, and data analysis is also another key, and is oftentimes overlooked components. we're dealing with a lot of data in these cases. Usually we collect flow and rainfall monitoring data every 5 minutes. So every 5 minutes you get a data point, and you have multiple sensors. Each sensor, sometimes you have redundant sensors. So there's a lot of data using a spreadsheet alone. It's not gonna it's not sufficient, and you definitely need to have some type of data management, data access management analysis platform. So in Civica, we have a sister company called Smart City Water, and we use our Smart City Water's data management platform, Data Current, to manage this data, to host the data, provide access to the data, and analyze the data as well. And the last but not least, the rainfall monitoring data is very critical to the success of the flow monitoring. Imagine if you do flow monitoring and you use a rain gauge that is a few kilometers away. The spatial variation, and sometimes rainfall is very localized here on the one side of the street. You can have a lot of rainfall, but on the other side of the street, during this summer snow event, it could be completely dry. So you want to have a rain gauge that is close to the centroid of your catchment area as possible. If this is hard to achieve, there are certain, I guess, techniques you can use, including something DRMT, distributed rainfall modeling techniques, which is basically using a few rain gauges around your catchment area and interpolate a catchment specific hydrograph for your catchment area specifically. And on top of that, we recently have also incorporated a radar data. We call it adjusted rainfall radar. So it's radar, but calibrated based on the ground measurements, which is the rain gauge data as well. So those advanced techniques are readily available nowadays. So this slide is to, I guess, illustrate some challenges associated with new subdivision in particular. So as you can see, on this drawing, there's different colors, so they represent different catchment areas. And usually for new subdivision flow monitoring, the catchment areas are relatively small. And as a result, so the flow we expect to see from those catchment areas are also very small. And on top of that, sometimes there is upstream and downstream relationship. So if you want to kind of tell, if for example, if a downstream flow meter is showing very high INI, whether this is because of the influence from upstream, or it's actually the subdivision that you're bracketing. So putting bracketed flow monitoring areas to isolate certain development of interest is also challenging, depending on where you pick up the site. You don't want to make the catchment area too small, and that creates a challenge to your monitoring data. And any error due to equipment, it's going to be significant, very significant. So it becomes very hard later on to do any kind of analysis if, for example, your flow is too low as a result of the catchment area. So yeah, this slide shows some of the equipment that we've been using for low flow conditions in new subdivisions. So as I explained, area velocity meter usually doesn't work very well in low flow conditions. So in the past, we tend to use a V-notch Weir, which is great for low flow. If you depending on how low your flow is, you can adjust the notch angle to increase the resolution or build up more head to do flow monitoring. However, there's a downside of those sharp V-notch Weir, is it's very prone to catch debris because of the narrow notch. So starting from this V-notch, we switched it to something we call it a box weir or compound weir, which is a V-notch weir at the bottom when the flow is low, and as the flow increases, so it goes up to a trapezoidal or sometimes a rectangular shape to allow more passage, more flow passage. So this type of setup allows ultra high resolution at the low end, but also gives us a high range of flow by changing the shape of the weir. And in the past 1 or 2 years, we also introduced, we developed a customized flume solution to deal with this low flow flow monitoring. So whenever when a site condition allows, meaning the benching has certain, I guess, length of strip benching, and by fitting a flume, which tends to have a better self-cleansing capability compared to a weir, we're able to achieve the resolution that we need to have for new subdivision, while keep the debris build-up level or the frequency of maintenance to a reasonable range. And to do so, there's some variation even in the flume itself. For example, some sewers, they are let's say they're 200 millimeter or 250 millimeters, and at the beginning the flow is very low, so we customized the flume to have an outer diameter that's going to fit into a 200 millimeter sewer or 250, 300 millimeter sewer, but the inner passage is much smaller. For example, 100 millimeter or even less to accommodate the initial low flow. So we call it a nested flume. So again, depending on the situation, there are different type of setup we would recommend or we would use. So this is a screenshot taken from a real new subdivision flow monitoring project. So what I want to show here is the debris buildup oftentimes is a challenge when it comes to flow monitoring operation. In this case, it's not too bad because the flow is not that low, but still it's on average it's probably 2 liters per second or less. And in the highlighted section, you can see there is elevated flow happened during certain days, and by looking at the hydrograph, you can tell there's some debris build up, so that caused the flow to be elevated. So that's going to trigger an alarm, first of all, on our side to go out and clean this monitoring site, get rid of the debris, but also in the data processing I guess work later on, you can compare these 2 days to the previous period. If the pattern is somewhat somewhat obvious, you can I guess correct the data, and QAQC can correct the data to eliminate the impact from debris buildup. Some other challenges, well, this is also associated with low flow and the flow diurnal pattern not being very obvious. So this slide shows a comparison between a older neighborhood on the bottom left side compared to a new subdivision monitoring site on the top right side. So as you can see from the hydrograph from an older neighborhood, you see the diurnal pattern is kind of obvious, and you don't see that much variation during dry days. In this case, there's some very obvious I&I response, but if we only focus on dry water flow, you can easily, I guess, determine a dry water flow for this site. And if you want to do I&I separation, then you can separate wet weather flow, I&I flow from wet weather flow relatively easily in this case. Whereas on the new subdivision data, as you can see, there's some spikes, and there's no obvious flow pattern or diurnal patterns you can see. And if depending on how low is the flow, if it's a very small catchment area, sometimes if somebody turns on, let's say, a washing machine or dishwasher, or even few houses they have shower going on, sometimes you see those spikes. And if those spikes happen even during wet weather conditions, it's a challenge to the data analyst team, if we want to separate those dry water flow from wet weather flow. And yeah, so we all know data quality is absolutely critical to any analysis. And before you do any analysis, you want to make sure your data quality is as good as it can be. we always say garbage in, garbage out. You want to make sure you can trust your data, and before you make your data to do any analysis and come up with any conclusions or recommendations based on your data. So what we do here is we always have a something called a QA/QC score. It's based on certain criteria, a few matrix depending on the site. That includes calibration measurements, mass balance, scatter graph, and data coverage. Depending on the site and the equipment setups, some criteria may not apply to certain type of sites, but those are customizable, and those are site specific. But what we normally do is, and this is what we're currently doing for City of Toronto and other municipal clients. Every month we would provide a report that summarizes the data quality score calculated based on these categories, and only the stations with a high score are recommended to use for any decision making. And the ones with poor scores, they obviously they will trigger some follow-ups, including troubleshooting the sites, or if the sites are deemed not ideal for flow monitoring, we would also propose to change the flow monitoring location or use another set of equipment to improve the score.
Awesome. And with that, we'll pass it over to Ed to talk about some of the data collection and management side of this.
Thanks, Matt and Alex. I'm happy to give you a good overview of some of the new technologies with respect to data analytics and management of these vast amounts of data that come in. It becomes a big headache unless I think Matt or Alex were both saying that you need to have tools to be able to handle all this data. I also like to report on some advances, both not only on the analytics side, but also on the practical field tools that we found, and some of it we've developed as well. Starting with robots that can be run during wet weather conditions and so forth. That we'll be more than happy to talk at some point in the future as well with you if you're interested. But for now, we're going to keep it to the analytics side, which is what I'm going to be describing in the next few slides. Starting with data current, I believe we mentioned that we have been using data current now for actually myself for almost 20 years. It's a cloud-based web-hosted data that incorporates a lot of analytic tools to allow us to clean the data, to evaluate the data, to report on the data, and also to take the data and calculate the wet weather response, the dry weather response, separate the groundwater from the rainfall derived infiltration and inflow. So these are key tools that you need to have to be able to run this cost effectively, even when you have so much data. So what we use as we mentioned, we use a product, Data Current, which is from Civica's sister company, Smart City Water. It provides real-time access to the data. It conducts real-time analytics, often during the storms themselves, and issues alarms if there is an issue, like Alex pointed out. If there's a shift, if there's a gradual buildup in the depth of flow, that's usually a gradual buildup in sediment in the pipes that shifts the depths. It could be also alarms due to voltage in the equipment that needs to be visited, the equipment, and replace batteries or whatever is needed is usually alarm. Nowadays, the system is tied to climate forecasts as well, so that we know when there's an event happening and we can be on standby, on alert to see what happens on the site. Because especially for new subdivisions, oftentimes you have to be there to see what's happening. You have to be at the surface if there's surface flooding, or you have to be in the pipe to see how that surface water, or what we call trench water, gets into the pipe as well, so we can identify defects right away and alert. If it is a new subdivision, alert the the developer, the municipality, the contractor, that and show them how the water is getting in, so that because oftentimes those defects are not found. I'm going to say most of the time, those defects are not found if you go there during dry weather. So having wet weather investigation technologies is key to I&I, successful I&I projects. Sorry, Matt. So ultimately, the system has to give you actionable information, such as, okay, there's an alarm of this type. We recommend that you go and visit the site. And so it tells you how much is being generated within each area as far as wet weather response. So you know where to do additional field investigations, which is what Alex does as well through smoke and dye testing, or like I said, through these robots that we are using nowadays as well. Data current is being used not just by us. There's contractors, there's other flow monitoring contractors that have approached us, and we've been more than happy to share the technology with them. We're all in a battle here with against basement flooding, environmental spills, and trying to gain capacity, optimize the use of existing infrastructure. So yeah, the technology is available to everyone, I would say. Okay, next slide, Matt. So these are some examples of the type of outputs we're getting from data current. All of this is subject to the equipment that you install or your contractors install. In this case, we're showing a rain gauge distribution map, sorry, not a rain gauge, a rain distribution map that is generated from various rain gauges. Alex also mentioned the use of radar data that is also incorporated with the rain gauges. But it's important for any I&I study, you need to know how much rain fell over the area that you're doing the flow monitoring. If a flow monitoring station reports little response, it could be because the area is very good, it's very tight, or it could be that the rain that you measured at a station 3 or 4 kilometers away did not fall over the catchment area that where you have the flow monitors. So you got to be able to generate the best possible rain data to be able to evaluate whether or not the area is a bad area as far as allowing a lot of I&I, or it's a good area that during large storms, it doesn't generate as much response. So having tools like this that can then project the amount of rain that fell over the area where you're monitoring is key. Bad rain data will give you bad interpretation of I&I. Next slide. And again, having tools like this that gives you a consistent approach, regardless of who's doing this, gives you consistent results of how the total flow is divided into a dry weather portion and a wet weather portion, the wet weather response. And so having tools like this that gives you a consistent approach, like I said, people could go on vacation. There's all kinds of people moving around in the industry, but as long as you do the analytics the same way every time and the right way is key to a consistent and a successful long-term projects. So this is an example of the I&I separation tool where you show the rain, where in this case, there's a rain showing from top to down. The amount of rain in this case is being used, I think, hourly time steps for rain, but you can also show it in 5-minute time step as short as the equipment data is coming into the system. And again, the flow data comes in typically as per the flow monitoring equipment settings. The time step is usually, Alex mentioned, 5 minutes, but sometimes we need to set the time step shorter for smaller new development areas because the time of concentration or the travel time in a new subdivision are usually also very slow. So, sorry, very short, not slow. It's low also because the flow velocities are low during low flow conditions. So again, and you see at the bottom here, all the analytics for each event that are provided so that you know the type of response that was generated from this area, this developing area. Let's go to the next slide. Again, so once you put together the rain and the flow response at each flow meter, you can start generating both event-based, what happened during a storm, or when you collect multiple storms, how that area responds, would respond during a large storm, whether or not you will exceed the capacity of your pipes. This is the type of map that you need to be able to interpret all of this data and tell you whether an area is a hot area as far as allowing a lot of inflows, or it's a fairly good area. Again, so we use color coding, thematic mapping, and this is also one of those key technologies that are used. Next slide. Having the ability to summarize the data into something, a table where you can rank each area. So in this case, at the left side, you see the station name that is being blanked out because I think we would reveal the location where this monitoring happened. But you want to be able to have these analytic tools. This system has to be able to summarize all the results and be able to rank it or to filter by certain results that gives you, alarms, so to speak, in terms of exceeding certain standards. And again, it gives you, from an asset management viewpoint, it tells you where your assets need a little bit more attention as far as doing further monitoring, further field testing, smoke testing, dye testing. So this gives you direction as to what the next step would be by having this result summarized in a way that you can, like I said, sort, filter, and so on by the different parameters that you see here. Let's go to the next slide, Matt.
Yeah, so we only have a couple minutes left, so we might just have to go through these.
And again, I'm just going to fly through this one. You see here what we're trying to highlight is every time that there's a parameter generated, there's a comparison with a standard. So the standard typically 0.26 liters per second per hectare. Anything above that, okay, let's pay attention to what happened there. Let's go to the next one. And again, some lessons learned about being present, especially in new development areas, in new construction areas, to see what caused the response in the flow meters. We can also put cameras. Oftentimes, contractors put security cameras on light posts, temporary light posts, where you can actually use that data to see what happened during a storm. In this case, we see sanitary manhole being completely submerged. And manhole I&I is probably the biggest non-defect that causes huge problems with I&I that we're going to quickly talk about it. Again, manhole I&I, what is it? Well, it happens because we're actually designing the streets to be channels, to be rivers during large storms. And in new construction, in new subdivision, this becomes even bigger problem because we block or we put filter material over the catch basins, grates, or under the catch basin grates, which can become easily blocked because they're there to trap sediments, so we don't fill up the erosion sediment control works downstream and the ponds. So what you see in the photo here is what happens more often than in existing areas. We have this type of road flooding that submerges sanitary manhole lids, and you only need 2.5 centimeters of head over a manhole lid with 2 peak holes to exceed the capacity of the pipe as far as RDII is concerned, the allowance that Alex was referring to. So dual drainage is just a technique that it's been done since the 1980s, believe it or not, or was done 1980s, 1990s. But we stopped doing it for some reason. And now the technologies have improved that we can do it even easier so that we can predict which manhole will become submerged. And oftentimes, more often than not, these manholes are not in low-lying areas. They are in areas where water is just flowing over the manhole lid and it's creating these huge sources. So that's what dual drainage is. Again, you're going to run a quick video here, Matt. This video is basically showing how much water gets in through the 2 peak holes and also through gaps around between the manhole lid and the frame. We can do this. It's not that hard to put in cameras, and we can do this test even without touching the lid by just measuring the water levels drawdown over time we create a bulkhead around the frame, and so we measure the lid, the inflow between the lid and the frame as well. But these are specific, especially shows the additional defects that are creating a lot of inflows through manholes that you would not think are in that bad a condition, but in some, depending on the head, they can generate. In some cases, we measure over 10 liters per second per manhole based on the head. And again, these are examples of dual drainage results that we've demonstrated that it's only about 10% of the manhole lids that need to be, if not fully sealed, at least partially sealed, because they are more vulnerable to becoming submerged during storms that are often less than 5-year return period. So, and if you have blockage over the grates due to fall leaves or high intensity storms that carry a lot of debris, the grates become, the grates to the storm sewer, catch basin grates become blocked. And then you have this effect that the road becomes the main channel as opposed to the sewers. So this dual drainage analysis is a technique that will allow you to identify manholes that are going to be susceptible to flooding at design time when you're designing the subdivision, or if it's an existing area, those are the manholes that are already susceptible to submergence and hence are the best candidates for doing some asset management improvement by going back and retrofitting some sealing technologies.
Awesome. So one of the last polls we have here now, so just trying to get a familiarity of the audience around dual drainage modeling and the value that it provides, either from previous experience or just maybe even from what you learned today. Would be interested to see if those, and I know we're coming up against the top of the hour here, so I want to move on and wrap up, and hopefully, I mean, I know we'll be more than willing to stick around and answer any questions. I appreciate if people have to leave, but yeah, we'll launch this poll. So it looks like about half of the audience is either very familiar or somewhat familiar, and then the other half not as much. So hopefully through this presentation, very briefly, we touched on it, you learned something, and then if there are any questions or if you want to learn more about it, we'd be more than happy to chat. So what's next? So yeah, feel free to reach out to us if you're looking to build your own programs, I&I prevention programs, I&I reduction. There's a lot of compliance that's upcoming with the new CELI, ECA regulations. If you're looking at performance monitoring for your various systems, collection systems, there are mandatory models and model updates that need to happen as part of those regulations. So sure, we're always looking for partnerships with other firms where we can explore opportunities to monitor flows, look at various solutions to maximize and create system capacity, and keep it in Q4. Those are listed there, and you can kind of take a look and see if that may be of interest to you. Finally, one last poll, just if you're interested in joining a working group related to stormwater and wastewater capacity management. Okay. I think my internet just kind of conked out at the end there. I don't know if it was a little sketchy, but hopefully everybody got the content, but at least could read in the slides. All right, so around 50% are interested and another 30% that said maybe. So we'll certainly reach out. It's something that we're looking at building and trying to get more people involved and talking about stormwater, wastewater, capacity management, everything involved with that. So keep an eye out for stuff from us, and we'll be more than happy to facilitate some of those conversations and working groups. So there are at least a couple questions. So again, I appreciate if some people have to jump off since it is now 2 o'clock. So thanks everybody for coming out, and hopefully you learned something. And again, we'll stay on for a couple minutes and answer any questions. I did see one from Elia, and nice to see his name pop up. So is York Region's target of 0.12 liters per second per hectare for new infrastructure acceptance day? So is that essentially, I guess the question is, is that what is considered acceptable at sort of day 1 or day 0, if you will? And I think that's essentially yes. The target at acceptance is that 0.12 for this program, for this particular program. 0.12 or less, essentially. So there's another question. So your flow monitoring and analysis seems to be referring to infiltration issues and or wet weather related. Can you clarify how inflow comes into play? Or would it be fair comment not to refer to I&I when you actually meant infiltration issues? So I guess like in terms of the analysis that we do as part of these programs, we actually look at both we kind of separate inflow from infiltration in a sense. So what we would call rainfall derived inflow and infiltration we look at. So as a clear response to a rainfall event, that is where you would do something like a wet weather flow separation and look at that result, the impact of rainfall on the flows in the sewer system. We also do, and unfortunately we couldn't get into too much detail around the infiltration side of things, but we do monitor during dry weather flow, for example, and we look at various ways of assessing infiltration. So there's various assumptions, industry kind of standards that you can make. There's also other methods, like a Steven Schutzbach method for evaluating infiltration as well. So there's a couple different ways we can separate the sort of two I's in I&I and look at them and evaluate the system. So I hope that answers the question as well. Another question, is there a perspective on I&I management for storm sewers? Is it becoming more common? For example, storm capacity management for flood mitigation. I think, and maybe Ed or Alex, if you want to jump in here, but I think for sure there's got to be some, some connection between the two. When you're, as Ed mentioned, when your storm sewers are built to convey, let's say, a 5-year storm, and the balance above that is conveyed on the street, and where your sanitary manholes are located and how that may impact I&I. I think there's certainly a case to be made to talk about those two systems interacting with each other, or we've seen in a lot of other studies where there's sort of exfiltration from the storm sewer into, and generally it's at a higher elevation than the sanitary. And so if they share a trench, how does that water get into sanitary sewers, for example? So I think there's certainly some aspect of that needs to be taken into consideration. I don't know, Ed, if you want to add anything to that, or?
Yeah, I would say storm drainage systems, yeah, they are also very important to make sure that you can carry the storm water either in the minor system, the sewers themselves, up to the capacity of the pipes, and which that's a question in itself, related to the amount of capture that you're allowing through the spacing and the type of catch basins that you put in along the streets. Mostly, sometimes you have catch basins elsewhere. Yeah, so there's the dual drainage topic that deals primarily. It came up primarily as a storm drainage system, capacity management. This is how you balance the flows between the sewers, because you want to capture up the 5-year storm. Typically around here we use the 5-year storm as the storm for sizing the storm sewers. So you want to capture the 5-year storm, usually without any surcharging of the storm sewer. But when you have a bigger storm above the 5-year, you will invariably capture, if there's no blockage in the grates, you will capture more than the 5-year capacity of the sewers, which is usually free flow. But then we do allow some surcharging. When the pipes become pressurized, you can still convey a bit more flow through the same sewers, as long as the surcharging, what we call the hydraulic grade line, doesn't go close or at or higher than the adjacent basements, house basements that are connected to through the foundation drains into the storm sewers. Yeah, we allow that, and we do the analysis up to the 100-year storm to see how much is being captured into the storm sewers and how much is left at the surface. So that's why we started doing dual drainage analysis back in the 80s, 90s. That has fallen off quite a bit. I did a bit of a survey recently of which municipalities are even checking, because some of them do have the requirement to check the capacity of the sewers, storm sewers, during events greater than the 5-year, because we size them using the rational method for carrying the 5-year peak flow. But the catch basins have a huge role in making sure that you do capture that flow and not more as well. And then the balance goes on over the surface. Yeah, in some cases, it is the overland flow and the storm sewer that creates a lot of this inflow into the sanitary sewers, as we mentioned before, by flooding the sanitary manhole lids. You only need 2 peak holes, 2.5 centimeters. Just remember that 2 peak holes typically that we use in every manhole lid, 2.5 centimeters to exceed the capacity allowance that we use for sanitary sewers. Okay, based on a certain manhole density, that's 2.5 centimeters. It's usually even less because the densities of sanitary manholes are higher than what we are assuming in this case. So yeah, storm drainage systems. Civica does as well an analysis and studies. We put flow meters in storm sewers just to see how much water is being generated by the area, runoff capture in the sewers, so that we can then calibrate models and evaluate larger storm events, both in terms of surface capacity and sewer capacity. I don't know if this answers your question, but yeah, monitoring is often necessary in storm sewers, even though there's a little bit more predictability in terms of how the storm sewers operate as compared to sanitary sewers, I should say.
Awesome. Thanks, Ed. So I don't see any other questions. So again, thanks everybody. If you have to jump off, really appreciate you taking some time, and hopefully it was informative. And yeah, keep an eye out on our various social media, LinkedIn, website. You know, we usually send a newsletter when we publish some information. We have a bit of a white paper that we're writing on this, and we have some upcoming content for future webinars, and further to some of the points Ed was making around manhole INI and some of the other programs we've been working on. So keep an eye out for that, and we'll be more than happy to share. So once again, thanks everybody.